In this lesson, we're going to talk about quadratic functions. A quadratic function in standard form is f of x equals ax squared plus bx plus c, where a, b, and c represents constants and a is not equal to 0. Think about if a is equal to 0, we would lose this x squared term and we would just be left with bx plus c, which if you remember from earlier lessons is a linear function. We're going to use an applet now to look at the effects of a, b, and c on the graph of a quadratic function. We're going to start off by looking at the most basic quadratic function, which is y equals x squared. Okay, so I'm going to be moving these sliders over here, and we're going to look at the effects that a, b, and c have on our quadratic function. So I notice that if I have y equals x squared, I have this shape, which is called a parabola. Okay, I'm facing upwards. If my value of a gets bigger, I notice how I remain an upward parabola and that the width of my parabola gets thinner and thinner because we could see that we're going to be increasing faster and faster along the parabola. If my a value is negative, we see that the parabola has now flipped downward. And again, as we have a larger negative value, the parabola gets thinner and thinner. So A changes the direction that my parabola is in, and the magnitude of A changes the width. Now let's look at the effect that B has on the shape of our parabola. So I'm going to start again at y equals x squared. When B is a larger positive number, I notice how my parabola is shifting horizontally to the left. And when b is a negative number, my parabola is shifting horizontally to the right. Okay, let's look at the effect of c. When c is a positive number, I notice that my parabola is shifting vertically up, and a negative number, it's shifting vertically down. Okay, when I move b and c together, I notice how it's shifting the center of my parabola. And we're going to talk a little bit more about the relationship between a, b, and c and the center of my parabola. Okay, then we have the vertical intercept. So just like any function we have, our vertical intercept or our y-intercept can be found by setting x equals 0 and then finding that y value. Okay, and lastly, we're going to want to write it as an ordered pair. Now if we think about f of x equals ax squared plus bx plus c, and we set x equal to 0, we see that we have a times 0 squared, b times 0 plus c. So f of 0 is just going to be the c value. So our vertical intercept is really the value 0, comma c. Okay. If we remember what our parabolas look like, either upward facing or downward facing, we see that they are symmetric. Okay, so that means we could take a line and slice the parabola into two equal halves. Okay, that line that we can use to slice the parabola into two equal halves is called the axis of symmetry. Okay, there is a formula for finding the axis of symmetry, and that's x equals negative b over 2a. Again, where b and a just represent those coefficients depending on the function. Okay, this point here is the center of our parabola. So we see that the axis of symmetry actually goes directly through the center. This point here is called our vertex. So again, if I have my parabola, I have my axis of symmetry, and I have the turning point, that center of my parabola. So since it's on the line, of the axis of symmetry, the x value can be found by just doing the negative b over 2a. It's on that line already. To find the y value, we just take that and plug it back into the function. So let's look at this function. F of x equals x squared plus 4x minus 12. Okay, so if we look at that function, the direction of it is definitely upward because the value of a is a positive 1. Okay, my vertical intercept, remember, is 0, comma, and then the c value. In this case, it's negative 12. Okay, my axis of symmetry, so remember it's x equals negative b over 2a. So remember this is a, this is b, this is c. So x is equal to negative 4 over 2 times 1. When we simplify that, x is equal to negative 2. That's my axis of symmetry. And my vertex, well, we already know half of the vertex, since, remember, the vertex is on the axis of symmetry, so the x values are the same. Let's find the y value. F of negative 2 is equal to negative 2 squared plus 4 times negative 2 minus 12. So I have 4 minus 8 minus 12, which is a negative 16. So negative 2, negative 16 is my vertex. Okay, last thing we're going to look for are the horizontal intercepts. So remember the horizontal intercepts are a number, comma, 0. So the output is 0. 0 is equal to x squared plus 4x minus 12. And we're going to try to solve this by factoring. X plus 6 and x minus 2. So we have two horizontal intercepts here. X is equal to negative 6 and x is equal to positive 2. So negative 6, 0 and 2, 0. Okay, we can actually use all of this information to draw a really quick sketch of our parabola. So I'm going to do that over here. So I know it's upward facing. I know that there is an intercept at 0, negative 12. So negative 3, negative 6, negative 9, negative 12. 15. Okay, I know that the axis of symmetry is at negative 2 and that the vertex is at negative 2, negative 16. So here's my axis of symmetry. And I have my vertex at negative 2, negative 16. I have intercepts at negative 6, 0 and 2, 0. So I can draw my parabola. Okay, so we were asked to also find the domain. So remember, if I go on my number line, domain is all the possible x values. Every x value is being used, so it's negative infinity to infinity. Okay, the range is my y values. Again, if I look at the number line from negative infinity to positive infinity, I notice that the smallest value that my parabola is going to use is negative 16. And it goes all the way up to infinity. Okay, then we talk about the interval that we're increasing and decreasing on. So if I go from, again, left to right, Okay, my parabola is increasing from an x value of 2 all the way to positive infinity. And my parabola is decreasing from negative infinity to 2. Another form that we can write a quadratic function in is in vertex form, which is f of x equals a times x minus h squared plus k, where hk is the vertex and a is a constant that's not equal to 0. So let's write the vertex form of this parabola in standard form. So I have f of x equals x squared minus 6x minus 1. So the first thing I need to do is find the vertex. So I'm going to start by finding the x value. Remember, we find the x value of the vertex by using the formula negative b over 2a. Okay, when I plug in the values of a and b, I get x is equal to 3. Remember, we find our f of x, or y value, by plugging in 3 into the function. So f of 3, after I do all my simplifying, is equal to negative 10. So my vertex is 3, negative 10. Now all I need to do is plug in the vertex into this formula here. So f of x is equal to 1, since my a value we could see as 1, times x minus 3 squared minus 10.